In this section, we're going to learn about law of sines, which is a method used to solve oblique triangles. Oblique triangle is just any triangle that does not have a right angle in it. So this gives us another option besides, using opposite adjacent hypotenuse and using Pythagorean theorem, because those things will only work if you have a right triangle. So if you don't have a right triangle, you have what's called law of sines, and you also have what's called law of cosines that we're going to look at later. These are the two situations in which law of sines would work. If you are given angle, angle, side, so if you have two consecutive angles and then the side immediately following this angle, then that's that combination of angle, angle, side. The other situation that will work for law of sines is if you're given angle, side, angle. So you would have to have the side that's immediately between these two angles, for instance, in order to use law of sines. Now your formula that you're going to have for law of sines looks like this. You just have where these are all proportional to each other. Sine of angle A divided by side A is equal or proportional to sine of angle B divided by sine B, which is also equal to sine of angle C divided by side C. Now you'll actually only work with these two of these ratios at a time, so it may be that you're saying that this one is equal to this one, or it may be this one is equal to this one. Again, just depending on what information you're given and what you're trying to find, so make sure that you copy that down in your notes. Okay, the first example we have is this one. Now, in this situation, you wouldn't necessarily have to draw a triangle, but as we do some other things later on, always having a picture makes it a lot easier. So I'm just going to sketch one off real quick. Doesn't matter if if it's in proportion or not, or true to size. So just draw you off any oblique triangle. Of course, you'll need to label A, B, C. So I'll just go around. This is angle A, angle B, angle C. Okay, so I'm given angle A to be 80 degrees. So like I said, obviously this is not true to size, which is fine. Angle B is 30 degrees. And we know side B is 14. And you're asked to find side A, which would have to be this bottom side. Okay, so using law of sines, since I'm trying to find side A, that means the numerator has to be sine of angle A. Okay, now my other triangle, since this is my variable, the other, not triangle, the other ratio that you're going to make here, you have to know the angle and the side, which you do. You know angle B and you know side B. So that will set up your other proportion or your other ratio. Okay, you're going to cross multiply. And in order to get A by itself, then you'll have to divide by sine 30 degrees. Okay, so this will be what you put in your calculator. So nothing tricky as far as entering that one in. Of course, make sure that you're in degree mode, so just do 14 sine 80 divided by sine 30. Okay, so I'm just going to round to the nearest tenth, so this is approximately 27.6. So there's your answer to that one. Okay, the next one we're going to look at. Okay, so again, if you need to sketch off a triangle, Okay, so labeling the information that I know that angle B is 40 degrees, C is 70 degrees, side C is 42, and you're trying to find side A. Okay, so again, when you go to set up your proportion, your first ratio, or the first one I want to write down, of course, is going to be the one that has side A in it, since that's what I'm trying to find. But if I'm trying to find side A, that means that I have to know angle A to put here. And that's not one of the angles that was given to me. But if you know two angles, then you can find the third one, because you've got a total of 180 degrees in a triangle. So just do your 180 minus 40 minus 70. Let me just write that down here. Of course, that's something you could do in your calculator, but angle A, 180 minus 40 minus the 70. So for angle A, we're going to end up with 70 degrees. Okay. Now your other ratio this time is going to consist of your side C and your angle C. So you've got both of those pieces of information, so you can make a ratio there. So again, sine 70 degrees divided by 42. Now because this one happened to be isosceles, of course you can just tell since your numerators are the same, you know what it's going to be here, but I'm going to go ahead and cross multiply and just go through the steps, because you don't always have one that's going to be an isosceles triangle. So we'll have A times sine 70 degrees is equal to 42 times sine 70 degrees. And if you were to then divide, but like I said, even if you get to this step, I mean, you could even say now at this point that your sine 70 degrees cancel, but whether you see that or put it in your calculator, it comes out to be 42. So there's your answer for that one. Okay, next one. Okay, so again, let's sketch off a triangle real quick. Okay, so angle A is 33 degrees, angle C is 82 degrees, side B is 18, and we're trying to find side C. Okay, so if we're trying to find side C, so for that ratio, I need sine of angle C, which is 82. Now, the other side that you know is side B, which is 18. So if this is side B, then I need to know angle B, which I don't know. So again, you could use subtraction. You know that you have 180 degrees in a triangle. Subtract the two angles that you do know. So that's going to give me angle B to be 65 degrees. Okay, so again, cross multiply. And then divide by sine 65. Okay, so in your calculator, you can just enter it in like you did earlier. Nothing tricky about this, no extra sets of parentheses or anything. To the nearest tenth, this would be 19.7. So there's side C.